So one thing to know is this video does have a lot of vocabulary in it, so it would not be a bad idea to, before you kind of dive all the way into it, to pause it and read through the vocabulary either from directly on the video screen or on your notes template. Definitely a good one to print out on the notes template because of the amount of vocab. I'm just going to touch on a couple important pieces. One thing is just the idea of concavity. So concavity deals with the slopes, the slope of the function and whether it's increasing or decreasing. So my first derivative determines what's going on with the actual function. Is it increasing? Is it decreasing? Well, the concavity says the function slope. Is the slope increasing or is the slope decreasing? If I am concave up, the graph of the tangent line will lie below the function. If I am concave down, it will lie above the function. So when I think of down kind of looking like a frown, and up kind of looking more like a cup. So just based on shape, then I can see that here it's concave down, and at some point it transitions and becomes concave up. That point where it transitions and changes concavity is called the point of inflection. It occurs when either the second derivative is 0 or it does not exist, so it's very similar to a critical number for a second derivative. But coming back to this idea here, if I am concave down, my tangent line is going to be above my function. And at some point, my concavity changes and I transition to having my tangent line below the function. And that point where it transitions, again, is called the inflection point. We will look at an example of this in class as well. So let's go ahead and look at some examples. So notice that because to determine concavity, I'm asking myself, is my second derivative greater than 0? If it is, it's concave up. Is my second derivative less than 0? If it is, it's concave down. It follows very similar rules to determining whether something is increasing or decreasing. So I'm going to use the second derivative, very similar to how I used the first derivative to guide me to find where something was increasing or decreasing or where there was a maximum, relative maximum or minimum. So we are going to look at two examples. I am going to change the second one to just be cosine of 2x, and we're going to look at cosine of 2x in class. So first thing I need to do is I need to go ahead and I need to find my second derivative because, again, I'm looking at where my second derivative is greater than 0 or is less than 0. Why this didn't copy correctly, I'm not sure, but this is an x cubed. So differentiating x cubed, I'm going to say my first derivative is equal to 3x squared minus 8x, and the 7 goes away. But again, I needed my second derivative, so I'll get 6x minus 8. So again, if I can find my inflection points, the inflection points being the spot where the concavity changes, then I can determine what's happening before it changes. Was it up or was it down? So my inflection points occur where my second derivative is either 0 or undefined. So I'm going to set this equal to 0. Then going ahead and solving this linear equation, I'm going to have 8 over 6 equals x, so 4 over 3. So again, I'm going to set up an interval, and I'm going to go from negative infinity up to 4/3, and from 4/3 up to positive infinity. Again, I'll pick a test point. So perhaps I pick 0 and 2. And then again, I'm going to go ahead and ask myself, what is the sign? And this time I'm going to do my second derivative of my test point. When I plug 0 back into my derivative, 6 times 0 minus 8 is negative. When I plug 2 back into my second derivative, 6 times 2 minus 8 is positive. So I can go ahead and say that I am concave down on the interval of negative infinity to 4 over 3. And I am concave up on the interval from 4 over 3 to infinity. But then I also need to find where is my inflection point. My inflection point is where I change concavity. So I change concavity here at 4 over 3. So I know I'm going to have an inflection point at 4 over 3. And this is the point that lies on my original graph. So I want to plug 4 over 3 back into my original function. So I'm going to find f of 4 over 3. Putting that into my calculator and going through the steps, I get 61 over 27, just following order of operations. And so now I know where I'm concave down, where I'm concave up, and where my inflection point occurs. Let's go ahead and look at the second example. So again, I changed that to cosine of x. So the first thing I'm going to go ahead and do is find my derivative, my first derivative, so I can find my second derivative. Cosine differentiates to negative sine, which then differentiates to negative cosine. And now I can say, well, where is this 0 or undefined? I can divide by a negative. And I know that cosine of x, thinking about my unit circle, equals 0 here at pi over 2 and here at 3 pi over 2. So I'd set up my intervals. Normally I start at negative infinity, but because they close my interval off, I'm going to go ahead here and say from 0 to pi over 2. From pi over 2 up to 3 pi over 2, and from 3 pi over 2 up to, again, 2 pi. Picking a test point. Well, thinking about my unit circle, I know pi over 4 occurs between 0 and pi over 2. And between pi over 2 and 3 pi over 2, I know I get pi. And between 3 pi over 2 and 2 pi, I know I get 7 pi over 2. Excuse me, 7 pi over 4. Now I can go ahead and plug those test points into f prime, f double prime, second derivative. And let's see, so I'll have negative cosine of pi over 4. Well, at pi over 4, I know cosine is positive. So this will be causative, so when I put the negative in front, that's negative. At pi, I know cosine is negative 1, so I'm going to have negative negative 1, which will become positive. And at 7 pi over 4, right here, cosine is my x value. I know I'm positive on my x values here, so I'm going to have a negative of a positive, which is negative. So again, I can say that I'm concave down from 0 to pi over 2, and from 3 pi over 2 to 2 pi. And I can say I'm concave up on pi over 2 to 3 pi over 2. And then I also lastly find my inflection point. Well, I know that that occurs when I switch signs. So when my concavity changes, so I switch signs, or my concavity changes at pi over 2 and at 3 pi over 2. So on this one I have two inflection points. So my first one is at pi over 2. My second one at 3 pi over 2. I have to find their corresponding y value by plugging back into my original function. So cosine of pi over 2 I know is 0, and cosine of 3 pi over 2 is also 0. So I have my concavity as well as my inflection points. So again, very similar process to finding where relative extrema are, but again, I'm no longer interested in looking at my first derivative. I'm looking at my second derivative because concavity deals with the increasing or decreasing of my slope of my first derivative.